Okay, so we're working on the word equations, which are more challenging because we have to make sure we get the formulas right. We've got to make sure we swap and drop ionic compounds. If we don't do that, okay, then we don't get the right formula and our equation won't balance, or it won't balance correctly. Okay, now after watching period 1 work on these, okay, we realize there's one other place where people are forgetting something, and that is the special elements. All right, if you take out your periodic tables, okay, remember that the special elements are color-coded on your periodic table, and they're listed in the top right-hand corner. There's a small box on the top right-hand corner, okay, that lists the polyatomic elements. Okay, and in there it says like H2, N2, O2, Cl2, I2, okay, P4, S8, okay, they're all listed there. It's important that in a word reaction, we remember to check if something that is produced is a special element. Okay, if it says, something reacts with oxygen, I have to remember that oxygen is always O2. Okay, or that nitrogen is always N2 when it's by itself. All right, and that's something that we noticed this morning in period 1, okay, that people were forgetting to look for. Okay, so we got to make sure we drop and swap correctly, but we also have to be on the lookout for special elements, either being a reactant or a product in the reaction. Okay, so what I would like you guys working on right now are questions 7 through 10. Okay, every couple of minutes I'll walk through another one, okay, so you can kind of compare your answers as we go. All right, so remember that we're identifying the reaction type, we're writing it out in formula form, and we're balancing it. Okay, that's what we're doing today. Now, sorry, for the rest of the week, okay, tomorrow, okay, will be kind of more reaction stuff. Your quiz will have some reaction stuff on it, like what we're working on today. Okay, Friday, we're going to have the Chromebooks, and we're going to do our pre-lab stuff for the reactions lab and talk about how to predict the products of a reaction. So Monday, we can do the lab. All right, so that's where we're headed. Then next week, we'll work a little bit more on reactions and start the mole equations, and you will have a unit exam on March 16th. Okay, so that is more than 2 weeks away. Okay, just make sure you've got it in your calendar so that you're starting to look ahead to that. If there's things you need help with, then make sure you're popping in at lunch or scheduled help. Okay, to make sure that you're getting those things figured out by then.
What unit do we have yet? What units do we have next?
You have biology next. Okay. All right, so let's get going on these ones here. All right, so on number 7, we've got dodecane, C12H26. All right, so we just write C12H26, and it's reacting with oxygen gas. Okay, and that's going to produce carbon dioxide and water. All right, what kind of reaction is that? It's a combustion reaction. Okay, do we have special rules for balancing combustion reactions? Do we need them both for this one? We do. Okay, 12 is an even number, so we need to apply the rule of 2. So we will, and then we'll balance in alphabetical order. All right, so starting with my carbons, 2 times 12 is 24. So I need to go over here and make sure that I have 24 carbons. Okay, next I need to balance my hydrogens. 2 times 26 is 52. Okay, so I'm going to go over here and make sure that I have 52 hydrogens.
That's 26.
Times 2. Oh, yeah. Okay. All right. And then I've got to balance my oxygens. So 24 times 2 is 48. So I've got 48 oxygens here in the carbon dioxide plus another 26. Okay, which is going to give me a total of 74 oxygens. Everyone okay with that? Okay, so 74 divided by 2 should be 37. Okay, so 37 oxygens there. Now, on a test, I would never give you one that would require such large numbers. I would give you a much simpler one like C2H6 or something like that, okay, so that you weren't having to, do such incredibly hard multiplication and division in your head. Okay. All right. Questions on number 7? How many people have done number 8? Okay, let's go over number 8 as well then. Okay, so this is one of the ones I was talking about before when I was saying it's really important to be on the lookout for special elements that could be part of a word reaction. Okay, so in this one we have lithium nitride, which is an ionic compound. All right, so I'm going to write lithium, which is a +1, and nitrogen, which is a -3. And then I'm going to drop and swap. So Li3N is lithium nitride. And it says it breaks down into nitrogen and lithium. Are either of those special elements? Yeah, nitrogen is a special element, and it always comes as a gas, but as a 2. Okay, whenever nitrogen is by itself, it's N2. Okay, now here's why that's important. If I don't have that 2 there, I'm not going to get this thing to balance correctly. I may not get it to balance at all, but I won't get it to balance correctly. Okay, so now I want to balance this reaction. So I'm looking over here. 3 is my biggest number, but if I just go over here and put a 3 in front of the lithium, that's not going to balance my nitrogens, is it? Okay, so I'm going to balance the nitrogen first. This is one of those like 5% of reactions where that start with the biggest number thing actually doesn't work the first time. Okay, so I'm going to put a 2 in front of this, and now my nitrogens are balanced. How many lithium does that give me? 6. So I need to go over here and put a 6 in front of lithium. Okay, now in terms of marks, here's where the marks get distributed if you were doing this on a quiz or a test. Okay, you would get 1 mark for your reactants. You would get 1 mark for your products. You would get 1 mark for saying that this is what kind of reaction? Decomposition. Okay, and you would get 1 mark for having it balanced correctly. So, if I forget that nitrogen is a special element, it's supposed to come as a 2, I will lose the mark for the products because I won't have the products correct, and I'll lose the mark for the balancing because I won't balance it correctly either. All right? So, 1 mistake like that, and you lose half the marks on a reaction. So it's pretty important to be on the lookout for special elements whenever you're writing a reaction from word to formula form. Okay, ready to get me there? I think I've harped on that. All right, keep going on 9 and 10. I'll give you a few more minutes to get ahead of me. Okay, so on number 9, I've got hydrogen sulfide. Is that an ionic compound or a molecular compound? It's ionic. Hydrogen's acting first, so it's acting as a metal. Okay, as long as hydrogen is listed first, it's acting as a metal. Remember, it is on the left side of the periodic table, okay, where all the metals are. Okay? So we've got hydrogen sulfide. The reason I ask whether it's ionic or molecular is because we have to drop and swap it. Okay, H is a +1 and sulfide is a -2, so we got H2S for hydrogen sulfide. It reacts with calcium hydroxide, also an ionic compound. So Ca2+ and hydroxide, which is a -1. Okay, when I have a polyatomic ion and I have to drop and swap, then I have to put what around it? Brackets. Okay, that's going to produce calcium sulfide, Ca2+, sulfur -2, so that one's okay, and water. Okay, weird thing. I wrote water in this reaction as HOH, but in the combustion reaction, I wrote it as H2O. Why the difference? Okay. Not so much that it's a different type of water. Either one would be pure water. I've just written it differently.
I guess because it's like hydrogen and then hydroxide, so it just goes over, you know? Like,
Yes, exactly,
Yeah.
actually. Okay, it makes it easier for me to track where every part of it came from in this type of reaction. In a combustion reaction, it's better for me to write it as H2O because I'm separating the hydrogens and the oxygens. Okay, in this reaction, I'm separating hydrogen from hydroxide. So if I write it as HOH, it's easier for me to tell where all the parts come from, and then later, easier for me to balance. I'm not trying to figure out, okay, where did the H's come from, where did the O come from? Oh, they were together before. Okay, so whenever you have a replacement reaction, you're going to want to write water as HOH. Okay, it's just easier to track where the parts come from that way. Okay, it's still water, it's just written different. Okay, so this is what kind of a replacement reaction, single or double? It's double, right? They're all ionic compounds, so this is a double replacement reaction. Okay, now I need to balance this. What should I balance first? I should balance hydrogen or hydroxide. They're both 2s and they end up together on the other side. Okay, so there's 2 hydrogens over there. Now there's 2 hydrogens over here. And that 2 gives me 2 hydroxides, which works out great because there's 2 hydroxides over here on the reactant side. Okay, there's 1 calcium, 1 sulfur, 1 sulfur. That was the only number I needed to put in. Okay, now the reaction is balanced. Okay, questions on number 9? All right, how many people have done number 10? Okay, let's look at that one too. Okay, so we got phosphorus reacting with oxygen, and we're producing triphosphorus dioxide. Here's another one where we need to look for special elements. Okay, phosphorus, when it's in its element form, is P4. Okay, and it's reacting with oxygen, which when it's in its element form is O2. Okay, and then that's going to make triphosphorus, so P3O2. All right, what kind of reaction is that? It's a synthesis reaction. 2 elements are combining to form a single compound. Okay, now I need to balance. What should I balance first? Phosphorus, yeah. There's 4 on one side, 3 on the other. What's the best number to balance 4 and 3 with? 12, yeah. Okay, so I'm going to put a 3 here because 3 times 4 is 12. And then I'm going to put a 4 here because 4 times 3 is 12. Now my phosphorus are balanced. Putting that 4 over there gives me 8 oxygen. So what do I need to put in front of this oxygen? 4. Right. And now the reaction's balanced. Okay. Everybody good with that one? Yes. All right. So here's what we're going to do now. I'm going to number you off. Okay. Whatever number I give you, that's the board you go to. Okay. And you're going to work with your group. Okay. On these ones. The reason number 8 is tricky is because oxygen is in every single piece of that reaction. Okay, it's in both the reactants and in the product, right? So we have to remember that we have to add those up, okay? Add up all the ones on the reactant side, they have to equal the ones on the product side, okay? So first off, let's see what kind of reaction is this, because it's a little different. It fits kind of one of the patterns, but not totally, okay? We have 2 reactants and only 1 product. What kind of reaction has only 1 product and 2 reactants? Synthesis. Now I know your notes say that most of the time it's 2 elements reacting to form a single compound, but a synthesis reaction is basically any number of things added together to form 1 product. Okay, so this is a synthesis reaction. Okay? And now we're looking at balancing this thing. Okay, so we've got sulfur dioxide here reacting with oxygen here to form sulfur trioxide over here. Now on this side there are 3 oxygen atoms. On the reactant side, there are 4. Okay, so what's the lowest multiple of 4 and 3? 12. Okay, so I'm going to go with 12. Now, if you've already looked at the answer to this or you've got it done already, you're going to see that what I'm writing is not right, but I'm going to fix it. Okay, so I'm going to start off with saying my lowest common multiple is 12. So I'm going to start here and make sure that I have 12 oxygens on my product side. Okay. When I do that, it gives me 4 sulfur. So I'm going to go back over to the reactants and make sure that I have 4 sulfur. Everyone with me so far? Okay. Now, I've got 12 oxygen on the product side, and right now, I have 4 times 2 is 8, and I need how many more? 4 more. Okay, so what do I need to put in front of the oxygen? Okay, now, the reaction's balanced, but is it correctly balanced? No. What do I need to do with all those numbers?
Well, you could just divide them by 2.
Exactly. I need to get it in the lowest terms. 4, 2, 4 can be lowered or reduced to 2, 1, 2. And that's going to happen sometimes. Sometimes you'll pick a number that can make an equation balance, but it's not balanced in its lowest terms. So you always have to check. Can I reduce these numbers at the end? Okay? All right. Any other ones giving us trouble? Okay. Keep working on those, guys. I'll put the questions back up here. Now, remember that as you're going along here, okay, these ones are kind of the easier ones, right, where we already have the formulas written out, but when you get past number 13, okay, we start moving into the word reactions where we have to write the formulas ourselves, and remember, those are a bit more challenging.